In continuation with the previous video, we'll continue to do more questions, more MCQ question based on quadrilateral. So if I see the next question, it says the diagonal AC and BD of parallelogram ABCD intersect at O. So let's say if I make a parallelogram and I name this as A, B, C, and D. Now it says the diagonals intersect at O. So let's say if I join this AC and the other diagonal, that is BD. And the point of intersection is given as what? O. Further, I can see we know the value of angle BOA. This is BOA. How much it is? 68 degree. And angle CAD, with CAD at this angle is given how much? 25 degree. Then what we have to find out is angle DBC. Where is DBC? DBC. This angle is what we have to calculate. Right? We have to get this angle is what we have to get. Now what I'm going to do here is, let's say, we know that this is a straight line, right? So we can apply linear pair over here. So we can find this angle. So one more time, we can see that it's a straight line. So applying linear pair, I'll get the value of angle AOD. And how much it should be? It should be 180 minus 68, right? One more time. As you can see, this is forming a linear pair. So this angle AOB should come as how much? 180 minus 68. And how much it is? 112. So this is 112 degree. Now, if you know this value, this angle, then we can apply angle sum property in this triangle. So by that, I mean to say we can apply angle sum property in this triangle. One more time, I'll show you that in this triangle, we know the value of two angles. So we'll get the value of third angle. So it should be how much? 112 plus 25, whatever it comes, minus 180 degree should give you the value of this. So I got the value of this should come as how much? It should come as 43. Yeah. Now check here. What I mean, you can see that here, if I just can show you once again. Yeah. Look into this. We are given these. Sorry, where is that gone? Yeah. So you can see that here, this line and this are opposite sides of parallelogram and they are parallel. Considering this as the transversal, what I can say that this angle should be equal to, one more time, this angle should be equal to this angle by alternate interior angle, right? So we can say that the value of this angle will be same as this, and that is 43 degree. Yes, I can see we have an option 43. That is option B is correct in this case. In the next question, it says in a parallelogram PQRS, PQ is 9 and PS is 5 centimeters. So let's draw the parallelogram first and then we'll continue reading it. So you can see that we have a parallelogram named as PQ, R, and S. And the length of PQ is how much? Given as 9 centimeter, and that of PS is how much? This is 5. Yeah, this is 5 centimeter. Now, what does it says? The bisector of P meets SR at A. So, okay, let's first make the bisector of P and make it meet this SR at point A. So this is A, right? And it says PA is produced, PA and QR are produced to meet B. So we need to produce PA and QR. All right. So these being produced, this is being produced, and I'm going to produce this also. Right. They're produced to meet at say point at B is what they're saying, right? Now what we have to find out, therefore, the length of RB. So where is RB? RB is what we have to get. This is the length of this RB is what we have to get. Now, first of all, we have these two angles as equal mentioned. That is this being bisector. So I can write angle 1 is equal to angle 2. And this will be 5 from the opposite sides of parallelogram. This will be 9. Let's figure out first thing that we know angle 1 is equal to angle 2. This is given and we can use alternate interior angle, right? So where should we apply the alternate interior angle? Let's figure out that here. If I apply alternate interior angles here, I can see that this line being parallel to this, and we can use the transversal to get this angle. Well, is it helping us? As of not now. So we are going to use the other one, right? I'm going to apply these two being the parallel lines and taking this as the transversal. Yeah. So now here I can say this angle 3. So let's understand once again. Angle 1 is equal to angle 2 is what given, and we proved angle 2 is equal to angle 3. That's by alternate interior angles, right? Alternate interior angles. So from these two, I can say 1 being equal to 2 and 2 is equal to 3. So 1 is equal to 3. Now check if these two angles are equal. All right. We check here first of all. All right. Let me remove this. Now you need to consider this triangle first. Check here. In this triangle, what we know that here we prove two angles equal like this and this. So using isosceles triangle property, what we can say that the length of AS should be equal to PS. And how much is PS? PS is 5. So this is 5 again. Now, as we know that opposite sides of parallelogram are equal. So this length SR must be how much? 9. So if the whole is 9 and SA is 5, so it's going to be 4. This will be 4 from here to here. That is AR. Now what else? I can see that this angle will be equal to this. Now what should I name it? Say angle 6. Angle 3 is equal to angle 6. And moreover, we know that by alternate interior angle, angle 1 is equal to angle 7. So let's write it down. If I write it over here, what we have one more time, angle 3 is equal to angle 6. That's why vertically opposite angle, and angle 1 is equal to angle 7. That's by alternate interior angles. So, but 1 and 3 are equal. We have already proved angle 1 is equal to angle 3. This implies angle 6 is equal to angle 7. Now here we have to consider this triangle, right? This one. So you need to look into this triangle. Here too we have two sides as equal. So I'm talking about this triangle. Here two sides are equal, and what are these two sides? We have this length, this angle, right? So angle 6 is equal to angle 7. So their opposite sides will be equal. So opposite side one is this and the other is this. These two sides will be equal. So clearly this is going to be 4, right? As this is 4, so this should be 4 again. So that's what we are supposed to find out, and I got the answer as the B is the correct answer in this case. So the next question says M is the midpoints of side CD of a parallelogram ABCD. So let's begin with first making a parallelogram. Let's say I made a parallelogram and I name it as ABCD. That's what it is mentioned. Further it says a line through C parallel to MA. So let's first join MA, then we'll get an idea. M is the midpoint, right? M is given the midpoint, and we have to draw a line through M, and that is drawn. Let's say first I'm going to draw this line, and what do we know? That this is midpoint, right? That means we have been given DM is equal to CM, and we are given a what is there? A line is drawn through C and parallel to MA. So and it meets DA produced to R. So let's understand what they are saying, that we are going to draw a line through C and it is drawn parallel to AB, AM, and it is meeting DA produced. So that means when DA is produced like this, when DA is produced, it is meeting like this at point R. So let's read it again to verify what we have done. It says a line through C parallel to MA intersect AB at point P. So that means this point is P. And when DA is produced, it is meeting the same line at point R. Further, we are given the length of DA as 3 centimeter, 3.5. DA is 3.5. Right, this is DA only. Then we have to get the length of DR. That is, where is DR? Yeah, this is what we have to get, right? DR. So in short, we can say that if we get the length of AR, we can say that we can calculate the length of DR. Now, the property which we are going to apply here is what? The converse of midpoint. Right. So for that, you have to consider this triangle. Let me show you the triangle I'm talking about. Let's say I draw this. As I said, we are going to apply the converse of midpoint theorem. So I'm taking this triangle. So in this triangle, what we know that M is the midpoint of what? DC for one side, and this line, that is MA, is given parallel to CR. So by converse of midpoint, what we can say that A must be the midpoint, right? A has to be the midpoint of DR, right? So in that way, we can say that AR should be equal to AD. And AD is how much? 3.5. So AR will also be 3.5 centimeter. But then this is 3.5 and this is also 3.5. So we can say therefore the total length DR has to be how much? 7 centimeter. Yes, we have an option, that is option C is correct in this case. So in the next question, it says ABCD is a trapezium in which AB is parallel to DC. So let's first make a trapezium. And now what do we know about this trapezium? That now let's say AB is drawn. So I must name this as AB and say this is CD. These are parallel. And further it says that M and N are the midpoints of AD and BC. So I'm going to take M here as the midpoint of AB and N being the midpoint of BC. And we are given some length. So let's first join this MN. Right. So as I can see from the further information, it says that the length of AB is 12. So I should write the length of AB. This is 12 centimeter. MN is also given. The length of MN is 14 centimeter. And what we have to get the length of CD, right? So if you remember the property of intersect, when three lines are given parallel and if they make equal intercepts, right, then there is a relation that this length MN should be how much? Half of AB plus CD. Now check here, we know the length of MN and MN is how much? 14. So let's plug in MN as 14. This is half of AB. AB is mentioned as 12. And CD is what we have to get. We need to get the length of CD. So let's keep CD as it is. Now if I transpose 2 to this side, it's going to be how much? 28. And later if I transpose 12 to the left, it is minus 12, should be equal to the length of CD. And how much is this? This will come as 16. So the length of CD will get as 28 minus 12, that is 16 centimeter. So we have an option here, that is, yeah, this is A is the correct option in this case. Into the next question, it says PQRS is a parallelogram and A and B are respectively the midpoints of sides PQ and SR. So let's do till here. We can make a parallelogram here, say, and I should name it as PQRS. So this is PQRS. Further, we are given A and B as the midpoints of PQ and SR. So P is the midpoint, like these two are equal. Is it P? No, that's A. A is the midpoint and B is the midpoint of SR. That's done till here. Further, it says that AS and BQ meet the diagonal PR. Okay, so we need to first draw the diagonal PR. Let's say if I join this, this is the diagonal over here. So this is diagonal and this is meeting AS and BQ. That means we need to join AS and BQ. So A to S, right? This is A to S and B to Q. So we'll be joining B to Q as well. This is B to Q. These two are joined. Okay. And they are meeting at point what? At point C and D. So the first must be C and this must be D over here. Then the length of CD is what we have to get. This length CD. That means we need to get the length of this CD. Is that? Yeah. This length CD is what we have to find out. So this can be done using the converse of midpoint theorem. Let's begin with considering this triangle. I just said it. Yeah. Look into this triangle. What you can see that here A is the midpoint of PQ as these two are equal. But then we need to prove this as a parallelogram first. So let's begin with the first step where we are going to prove this figure a parallelogram. We are going to prove this figure as a parallelogram in order to prove what we have to do. So we can say from here that we have PQ length. The length PQ is equal to SR. So their halves will also be equal. And half of PQ I can write AQ and half of BC I should write BS or SP. Now even these two lines should be parallel, as you know that parts of parallel line are parallel. So check here, by that I can say from this that this should be a what? A parallelogram. So that is, I should write it down here, that is ASBQ is a parallelogram. Now once it is a parallelogram, we can write these two lines as parallel, right? As you can see, the whole lines can be written as parallel. So therefore, we can now apply the converse of midpoint. So we'll begin with, as we started, we can say that the triangle, this triangle, that is AQD. What we know here that A is the midpoint of PQ, and I can say that this line, that is CA, should be parallel to this. These two should be parallel, right? Reason, parts of parallel line, because we have proved this a parallelogram, and from here we can also say that this AS being parallel to BQ, so parts of parallel line are parallel. So by converse of midpoint, what I can say, C will be the midpoint of PD, right? So this way I can say that PC is equal to CD. So let's write it down. What we have obtained, PC is equal to CD, and the reason is converse of midpoint. Now we'll be considering another triangle. This time I'm going to consider this triangle. Let's say this one, right? This is the triangle, and that is, what's its name? SRC. In this triangle, what you can see here that B is what? B is the midpoint of SR, and we also know that this line is parallel to this as parts of parallel line. So BD is parallel to SQ. So I can say by converse of midpoint, D should be the midpoint of CR. That implies that CD should be equal to DR. One more time, this should be equal to this. So CD is equal to DR. That means all three are equal, right? So it's being trisected. And if you see the length of PR from here to here, it is mentioned as how much it is? 12 centimeter. So each will be 1/3. That means from these two equation, you may write down that PC is equal to CD is equal to DR. That implies each will be how much? 1/3 of the whole length. And the whole length is how much? 12. That implies it should be 4. So this will be 4, this will be 4, and this will be 4. Anyway, we just had to get this length and we'll say 4. That is C is the correct option in this case.